All right, so an event is the collection of one or more outcomes. The collection, let me get it right here, of one or more outcomes. The collection of one or more outcomes. So the possible results of a probability experiment, the collection of one or more outcomes is an event. Moving right along. Next one is called a sample space. Next word. Sample space. The sample space is the set of all possible outcomes. The set of all possible outcomes. So, the set of all possible outcomes. Let's go ahead and draw a picture of a sample space, an example of a sample space. So we just rolled a die. If I asked you, list the sample space of rolling one die, this is what it would look like. There it is. That's an example of a sample space. It can be a picture, it can be just numbers, it can just be letters, but go to write example. The set of all possible outcomes of the sample space. So this would be an example of the sample space of rolling one die. Or you could draw a simple picture. Little boxes. So it can be numbers, letters, or pictures. The main thing I want you to understand about a sample space is just a depiction of all the possible outcomes of a probability experiment. Let me do number 4, right, of a die. 5, and then 6. Sorry? So numbers, pictures, anything that depicts or conveys all the possible outcomes of rolling one die. So this would be example of rolling one die, the sample space. Rolling one die. Put that on your notes. I'm going to give you another example. If you can't fit it in between those two words, put this next example on the other side. Put flipping a coin. Flipping a coin. What's the sample space of flipping a coin? Heads and tails. So one way to depict the sample space is just put in letters. Look at H and T. Well, one can mean heads or tails, so that's not clear enough. That make sense? Well, if you say it that way, yeah. But then that's getting too convoluted. This is more straightforward. H is heads, T is tails. Also talking, but go ahead. Let's wait till we're done talking. Was it Moreno or Hernandez? Yes. Okay. Or it could be pictures. Look at little circles. I'll put a little head there. Looks like a goose. And I'll put the Capitol building for tails. So it could be a picture, it could be letters, it could be numbers. All it is communicating all the events of some event, all the possible outcomes. Okay, that's sample space. All right, questions so far? Grab a note guide. Here we go. Scotty. Next word is the probability of an event. Now, on this one's a big one here. So what I want you to do is for the probability of event, go ahead and write this just by the definition, but put this picture in the back of your note guide. Okay? In other words, a scale. So this is for the probability of an event right here. There's 50,000 chairs here. Just come closer. The probability of an event is a measure of the likelihood or chance that the event will occur. Probability is a number from 0 to 1, including 0 and 1, and can be expressed as a decimal, fraction, or percent. So copy this in the back of your paper. This scale of probability, put it in the back of your note paper, but this part is for the definition. Say again? I'm the master, what can I say? Thank you, Murillo. All right, now, before we start doing a lot of calculations on probability, what I want you to focus in on here is that whatever result we get of a probability calculation, the closer you get to 0, the more unlikely it is to happen. The closer you get to 100% or the number 1, the more likely it is to happen. Certain means it's going to happen. It will happen. There's no doubt about it. That's what certain means. Impossible, it's not going to happen. Who can give me an example? Well, we'll come back to it later. Let's do the next word. Next word. Next word is theoretical probability. Here we go. Here we go. Theoretical probability is, there we go. You see it right there? Theoretical probability is, I'm going to give you a formula. I'm trying to think of the way they're doing it here. Okay. I'm going to put equals. I'm going to write number of favorable outcomes okay, that's the numerator, number of favorable outcomes, divided by the number of total outcomes. Yeah, this is just a formula on this one. Theoretical probability, number of total number of outcomes. Okay. Now, experimental probability, right underneath, let's go and define that one. I'll do that one in blue, Dodger blue, since they won yesterday. Yasiel Puig got the game-winning double to win again. So here we go. The experimental probability are number of successes number of successes number of successes over the number of trials. Number of successes over the number of trials. Now we're going to do one example of both formulas after I answer this. On the back of your paper, example 1. Here we go. Find the theoretical probability. I'm going to put P for probability. Find the theoretical probability of rolling a 3 on a die. Find the theoretical probability. So when I say P, that just means probability from now on, because we're going to be doing a lot of probability. When you see capital P, that just means probability. Find the theoretical probability of rolling a 3 on a die. Now, theoretical means in theory, like a thought experiment. In other words, we're not going to pick up the dice. I'm not going to pass it. I'm not going to get this in my hand and start rolling it. I'm going to think about the formula that we just wrote down. What is the number of favorable outcomes that I'm looking for if I were to actually roll the die? Okay, so let's see. What am I looking for when I roll the die in my mind? A 3. So how many 3s are on one die? 1. So I'm going to put P of rolling a 3, the probability of rolling a 3, is equal to, here we go, we're going to use this formula now, right here. The theoretical probability formula, number of favorable outcomes. If on one die, there's only one face that has a 3, so that's 1 divided by, how many total? Right, there's total number of outcomes is 6. Done. So that's the likelihood of it happening is 1 out of 6 times. So this is if I write it as a fraction. Let's do it as decimal. I could leave my answer as a decimal. So let's see. 1 divided by 6. Watch this. 1 divided by 6. I'm going to do it as a decimal now. 1.1. I'm going to run the nearest hundredth, so it'd be 0.17. I'm running the nearest hundredth. So I'm writing it as a decimal now. So technically we're done, but I'm just showing you that we can write our final answer as a fraction, a decimal. Watch this, 0.17. That's a decimal. I'm going to put that in your notes. Or we can write it as a percent. 1 out of 6 is what percent? Well, I can do this, right, and then solve for x. I can do that if I want. Or I could just look at this decimal here. This is already at the hundredths place. That's 7. So it's really 17%. So I can write the probability as a fraction, a decimal, or a percent. They all mean the same thing. Just like MJ refers to Michael Jordan, his Ernest refers to Michael Jordan, Michael refers to Michael Jordan. All these different names mean the same thing. Same with probability. The probability of rolling a 3 is 1 out of 6, 0.17 as a decimal, or 17% as a percent. So would this be a likely event or an unlikely event? Likely? Where on the scale does it fall? So 17%. 17% is about right here, right? Gentleman in the back, I got the floor here. 17% is about right here, somewhere around there, right? So it's unlikely to roll a 3. Possible? Of course it's possible. We did it 49 times out of 250. But it's unlikely. So that's theoretical. Okay, now, Last example and we're done. You guys are doing excellent. Actually, you know what? That's the last one. You're the man. You're the man. Last example. Example 2 and we're done. Here we go. We're going to find the experimental probability. Now, ready? So here's number 2. Find the experimental probability of rolling a 3. So we did a theoretical in our minds of rolling a 3. It became 1 out of 6 or 17%. Now, experimental means actually doing the rolling, getting a dice in your hand, rolling it, and figuring out how many times it lands 3 out of how many trials. Look at the formula right here. Number of successes over number of trials. We did this in the beginning of class today. How many successes did we have rolling a 3? How many successes did we have as a class rolling a 3 today? That's there. So what we did there was experimental probability. Think of the word experience. You actually did it. You did the experience. It's experiment and experience have the same root word. So here we go. But P of rolling a 3 experimental is 49. The total number of trials, we added them all up today, 250. And we calculated it as what? 19.6%, huh? I did it right there on the board. So look at how far, we're going to end our notes now. Look at the experimental probability and look at theoretical probability. How far is the real life away from theory? Not that much. It's about, let's see, 2.6 percentage points away. Now here's a big kicker now. Right. Which became 17%, theoretically. But when we actually did 250 times rolling the dice, we found out that 19.6% of the time it came up 3. Now here's the kicker. This experimental probability gets closer and closer to theoretical the more trials you attempt. In other words, if we sat here all day and did like 10,000 trials, this number would get closer and closer to 17. So in the long run, experimental probability approximates closer and closer to theoretical. So we can't really predict, when you roll one dice, I can't predict if it's going to roll a 3 or not. But if you do it a lot of times in the long run, I can predict you're going to get 17% of the time. If you do this 1 million trials, 5 million trials, and just all day and for a year, how many times a 3 if you had no life? Imagine. This would get to 17%. That's kind of like the mystery of probability. Real life actually approximates theory. That's the big idea for today. Last 10 minutes, go grab your computer, work on assignment 1. I want to stamp you, so show me you're being productive. Yes? Hold up.